Pour milk over a bowl of cereal right now, and somewhere in that bowl, a war is being fought. Water is trying to invade every single flake, trying to turn it into mush within seconds. And yet, somehow, for minutes at a time, that cereal fights back. It stays crisp. It stays crunchy. How? The answer involves pressure cookers powerful enough to cook grain in seconds, ovens hot enough to blast away nearly every trace of moisture, and a coating so precise it's measured in fractions of a gram. This is how factories engineer a food to defy the laws of soggy breakfast physics. It starts long before any factory, out in vast fields of corn, wheat, oats, or rice, harvested and trucked in by the ton. These raw grains arrive at the plant already cleaned, but they're nowhere near ready to become cereal. They still contain hard starches, locked in a structure the human body can barely break down, and flavors that are, frankly, bland. So the first job of the factory is transformation, and that begins in a machine most people have never heard of, called a cooker. Here, grain gets mixed with water, sugar, salt, and flavoring, then sealed inside a massive rotating pressure cooker. Steam floods the chamber, temperatures climb, and pressure builds far beyond what your kitchen stove could ever produce. Under these conditions, the hard starch molecules inside the grain begin to break apart and gelatinize, a chemical transformation that makes the grain digestible and sets the foundation for that familiar cereal flavor. This isn't just boiling, it's controlled chemistry on an industrial scale. But here's where things get really interesting. After cooking, the grain isn't dry or crispy at all. It's soft, sticky, and full of moisture. Nothing like the product you'd recognize. So it moves into massive dryers, where hot air strips away much of that moisture, leaving behind something firmer, but still not final. This partially dried grain then heads toward one of the most oddly satisfying machines in the entire factory. Depending on the cereal, the next step might be flaking rollers, two enormous steel cylinders spinning in opposite directions with only a hair's breadth of space between them. The cooked grain gets crushed between them under intense pressure, flattening each piece into a thin, uniform flake in a fraction of a second. Watch this process in slow motion, and it looks almost hypnotic. A river of soft grain transforming instantly into crisp little sheets. For puffed cereals, the method is completely different, and honestly, more dramatic. The grain gets shot into extruders or puffing guns, machines that build up intense internal pressure and heat, then release it almost instantly. That sudden pressure drop causes the moisture inside the grain to flash into steam, expanding the piece violently outward in a fraction of a second, like a tiny edible explosion. This is the step most people never get to see, because it happens behind sealed machinery, faster than the human eye can really follow. Whichever shape the cereal takes, there's still a critical problem left to solve. At this stage, the pieces still contain too much moisture to survive a splash of milk. This is where the real magic happens. The flakes, or puffs, travel through massive toasting ovens, some using rotating drums, others using conveyor systems, where temperatures can climb high enough to drive out nearly all the remaining internal moisture. This toasting stage does two things at once. It develops that deep, roasted flavor and golden color we associate with cereal, and it dramatically increases the structural strength of each piece, hardening the surface into something rigid enough to resist liquid. But engineers didn't stop there. What happens next might surprise you. Many cereals get sprayed with a thin layer of sugar or a light glaze after toasting. That might sound like it's purely about taste, and flavor is part of it. But this coating also acts as a kind of protective shield. As it cools and hardens, it seals tiny surface pores on the cereal, slowing down how quickly milk can seep inside. It's the difference between a flake that collapses in 90 seconds and one that holds its structure for several minutes. Throughout every single stage, quality control teams and automated sensors are constantly checking the product, measuring moisture levels, monitoring flake thickness, checking color consistency, and pulling samples to test texture. If a batch comes out too moist, too pale, or structurally weak, it never makes it to your bowl. Once the cereal passes inspection, it moves toward packaging. And this is where speed becomes just as important as precision. High-speed packaging lines form the inner liner bags, often at incredible rates, filling each one with a carefully measured weight of cereal before sealing it airtight. That inner seal matters enormously because oxygen and humidity are the real enemies now. Even a small leak could let moisture creep in during shipping and storage, quietly undoing all that engineering before the box ever reaches a store shelf. The sealed bags drop into printed cartons, which are then packed into cases, stacked onto pallets, and shipped out to distribution centers, then finally to grocery stores, where they'll sit until someone tosses a box into their cart without a second thought. And that's the incredible part. Every single crunch you hear when you pour milk over your cereal represents pressure-cooked grain, flattened or puffed in an instant, blasted with heat to lock in crispness, and shielded with a microscopic protective layer, all engineered so that your first bite tastes just as crunchy as your last. Next time you're sitting there enjoying your breakfast, you'll know there was a hidden battle against sogginess happening in that bowl. And the cereal industry spent decades learning how to win it. If you enjoyed going behind the scenes of something so many of us eat every single day, make sure to like this video, drop a comment with what factory tour you want to see next, and subscribe for more fascinating journeys inside the world's most incredible manufacturing plants.